Hello guys, welcome back to the channel Mathemagix JEE. In this video, we are going to discuss this problem from the chapter of complex numbers. Here it says A, B, C are distinct complex numbers, okay, with mod of A equal to mod of B equal to mod of C equal to 1 and Z1 and Z2 be the roots of the equation AZ square plus BZ plus C equal to 0 with mod of Z1 equal to 1, okay. So we have this equation, right? Az square plus bz plus c equal to 0, right? And its roots are z1 and z2, and we have mod of z1 equal to 1, okay. Also let p and q represent the complex numbers z1 and z2 in the complex plane with angle poq equal to theta, where o is the origin, okay. So let's say this is our complex plane. This is imaginary axis, this is real axis, okay. And let's say this vector is corresponding to this complex number z1, okay. Then we have this second complex number, let's say somewhere here. It may be here or maybe here, right? So this angle is basically theta, and this point corresponding to z2, the complex number z2. So this is the point q, this is the point p, this is the point o. O is the origin, right? So we have this angle as theta, but note that it is not necessary that this length of this vector corresponding to z2 is equal to the length of the vector corresponding to z1, right? Because we are told that the angle between these two vectors is equal to theta. We are not told whether the lengths of these vectors are equal or not. The modulus of the two complex numbers are equal or not, right? Because we know the modulus of a complex number basically denotes the length of the vector joining the 2 points origin and that complex number, okay. So let's find out some informations about this z1 and z2 first, using the concept of quadratic equations. As we are dealing with a quadratic equation here, z1 and z2 are roots of a quadratic equation. So let's find z1 plus z2 first and z1 z2 first, okay. So z1 plus z2 will be simply minus b by a, right? And z1 z2 will be c by a, okay. Now we are given some information about the moduli of these three complex numbers, okay. A, B, C are distinct complex numbers, okay. They are distinct and they are complex numbers with mod of A equal to mod of B equal to mod of C equal to 1, right? So basically some information is given about their modulus. So our next step will be to take modulus in both sides of these two equations, because we are interested in finding the modulus. The information of modulus is given to us in the question, okay. So mod of z1 plus z2, let's find out. This will be simply mod of b, right, divided by mod of a, which means it is equal to 1, right? And then we have mod of z1 z2. This will be mod of c divided by mod of a, right? So this will also be equal to 1. Now mod of z1 z2 is we can write as mod of z1 times mod of z2, right? So this will be nothing but mod of z1 times mod of z2, which is again equal to mod of z2. Why? Because mod of z1 is equal to 1, so mod of z2 will be equal to 1. That means the length of these two vectors according to the given information are equal, okay. In a general case, they may or may not be equal, but in this case the length of these two vectors are equal, okay. So we have this z2 equal to some, let's say, z1 e to the power iota theta. Why? Because we have the angle between these two vectors, okay. Argument of this vector minus argument of this vector we can write as argument of this vector is z2 minus 0, right, divided by this vector is z1 minus 0, that means z1. This argument is equal to theta, okay. So we take this argument in the right hand side, or we can say that we are basically rotating this z1 in the counterclockwise direction in our case, because we represented this theta as a positive angle here. So we will be considering this as a positive angle, okay, counterclockwise direction. So we can say this vector is nothing but rotated about this origin by an angle of theta. That means we can say z2 equal to z1 e to the power iota theta. right? So we have to find this theta. Theta is nothing but this angle POQ. Okay, so let's find out. So z2 equal to z1 e to the power iota theta, we assume this. Okay, then we have to find the angle theta using this relation, because mod of z1 plus z2 is already known to us. How? We know by using the concept of resultant of two vectors. We can say mod of z1 plus z2 whole square will be nothing but mod of z1 square plus mod of z2 square plus 2 times mod of z1 times mod of z2 times cos of angle between them, right? Angle between them is theta, so cos of theta. So we can substitute the values here. We have 1 equal to 1 plus 1 plus 2 into cos theta, right? So we have cos theta equal to minus half from here. So theta is equal to 2 pi by 3. Okay. So that means theta is equal to 2 pi by 3. This is known. That means if we check the option, option D is eliminated from our answers. Okay. So let's check the other informations to find out the correct options. In this case, we have the two vectors of equal length, and the angle between these two vectors is equal to 2 pi by 3, right? So 2 pi by 3 like this. That means this point is O, this point is Q, this point is P, right? This is our Z1, this is our Z2. So we can say this PQ distance will be, if we drop a perpendicular from this O point to this side PQ here, this angle will be pi by 3, right? Each of these two angles will become pi by 3, and each of this side length is equal to 1, right? So this will be, this PQ length will be 2 times this length, right? Let's call this point M. So 2 times the length of PM. So PM length is nothing but 1 times sine pi by 3, right? So this will be 2 sine pi by 3. So this will be equal to root 3, right? So PQ equal to root 3, that means option C is also eliminated, right? So we have to check between option A and option B. Now what we have to check? We have to check whether this is true or not. Okay, B square equal to AC. Let's check. So we have Z1 equal to something Z1. Okay, Z1, the information about Z1 is not given to us. Z1 may be an arbitrary complex number lying on this unit circle. Okay, but we have some information about this Z2. Z2 is nothing but Z1 times e to the power iota 2 pi by 3, right? So e to the power iota 2 pi by 3 is what? It is nothing but our omega, the cube root of unity, complex cube root of unity, right? So this we can write as Z1 omega, because omega is more familiar to us than this form e to the power iota of 2 pi by 3, right? So if we check this informations again, Z1 plus Z2 equal to minus B by A. So we get minus B by A equal to Z1 plus Z2. That means Z1 into 1 plus omega, right? So this we can write as 1 plus omega is equal to minus omega square. That means we can write this as minus Z1 omega square, right? So B by A will be Z1 omega square, right? And then we have Z1 Z2 equal to C by A, right? This will be Z1 times Z2. So Z1 times Z1. So Z1 square times omega, right? So Z1 Z2 will be this, and B by A is Z1 omega square, and C by A we have Z1 square omega. Now we have to somehow eliminate this Z1. So we can do a thing here, that we can square this and divide by this. Okay, so if we square this, B square by A square is nothing but Z1 square times omega to the power 4, but omega to the power 4 is equal to omega, right? Because omega cube is 1. That means we can write this Z1 square omega. That means these two are equal, right? C by A equal to B square by A square. So we can cancel this A here, because mod of A equal to 1, which means A is not the point O, which is the origin. Okay, basically A is non-zero complex number. So we can cancel this A. So we have B square equal to AC, which means this is our desired relation. Okay, and we also had this pq equal to root 3. So this again is a valuable information. So let's check the option. We have theta equal to 2 pi by 3, pq equal to root 3. So this will be option B, right? And then we have b square equal to ac and theta equal to 2 pi by 3, right? So option A will also be correct, which means our correct options in this case will be option A and option B.